Can you solve this algebra challenge? Here's the question. Given that a plus b plus c equals 0, then the goal is to find the numerical value of a squared plus b squared plus c squared times the quantity a raised to the fifth power plus b raised to the fifth power plus c raised to the fifth power all over a cube plus b cube plus c cube multiply by the quantity a raised to the fourth power plus b raised to the fourth power plus c raised to the fourth power. Now pause this video right now and see if you can answer this question, because I will show you the answer and the solution in 3, 2, 1. Alright, let's have first the answer to this question. And the value of this expression is 5 over 3. Now the question is, how do we get the value 5 over 3? Now in this video, I will show you 2 different methods to answer this question. And let's begin. So we have 2 possible methods for this one. Although we have a lot of possible methods to answer this kind of question, but here's the 2 suggested solutions. So the first one is by using Pascal's triangle and a bit of factoring techniques. And the second one is by using Vieta's relation and a lot of identities. So let's begin with number 1. We have the Pascal's triangle with a bit of factoring techniques. Alright, so here's the Pascal's triangle. We have 1, 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, and so on and so forth. And those numbers corresponds to the expansion of a plus b raised to some power. For example, a plus b raised to 0 is just 1, so the coefficient is just 1. A plus b raised to the power of 1 is a plus b, which is 1, 1, the coefficients of a and b. A plus b raised to the power of 2 is a squared plus 2ab plus b squared, so the coefficients are 1, 2, and 1, and so on and so forth. Now in this video, we will use a plus b raised to the power of 2, a plus b raised to the power of 3, raised to the power of 4, and raised to the power of 5. So take a look at those expanded form. Now let's begin with our question. So let's get our equation, given equation a plus b plus c equals to 0. Now since in the binomial expansion, we have 2 terms a and b, so what we're going to do is to set this c in terms of a and b. So the value of c can be written as negative of a plus b. In short, we can replace all c in this expression as negative of a plus b. So let's get the first one. So we have a squared plus b squared plus c squared. This can be written now as a squared plus b squared plus this c can be written as negative of a plus b raised to the power of 2. Alright, and we will do the same thing to the rest of the factors. So sum of cubes, sum of fourths, and sum of fifths. Now from here, let's focus on the first equation. Or simply, I will focus here first on the numerator of our expression that we want to evaluate. So after a squared plus b squared plus c squared, I will next a raised to the fifth power plus b raised to the fifth power plus c raised to the fifth power. Alright. Now, negative of a plus b raised to the power of 2, this is the same thing as a plus b raised to the power of 2 because negative times negative is a positive. Now expand a plus b raised to the power of 2. Using Pascal's triangle, we have a squared plus 2ab plus b squared. Now simplify and combine like terms and factor. So a squared plus b squared plus c squared can be written now as 2 times the quantity a squared plus b squared plus ab. Now let's set aside this result. And now let's get the other factor on the numerator, sum of fifths. And we will do the same thing. But now, negative of a plus b raised to the fifth power, this becomes negative a plus b raised to the fifth power. This is just the same thing. Now expand a plus b raised to the fifth power using Pascal's triangle. We have this expression. And now what we're going to do is to eliminate some terms because a raised to the fifth power and negative a raised to the fifth power is just 0. Of course, b raised to the fifth power and negative b raised to the fifth power is just 0. So this remains as this expression right over here. And now let's factor out 5ab because 5ab is the common factor of this expression. And take note, this a cubed plus 2a squared b plus 2ab squared plus b cubed this can be factored easily as a plus b multiplied by a squared plus b squared plus ab. You can check this factorization on your own. Alright, so let's set aside this result. Now let's get one of the factors on the denominator. Let's have the sum of cubes. And again, we will do the same thing. This expression right over here is the same thing as negative of a plus b raised to the power of 3. Now expand this using Pascal's triangle. And then take note, we can eliminate a cube and negative a cube, b cube and negative b cube. So what's left is 3a squared b plus 3ab squared, or negative 3a squared b minus 3ab squared, and factor out negative 3ab. So this becomes negative 3ab multiplied by a plus b. And let's set aside this result. Now let's get the sum of fourths. And again, we will do the same thing. Expand this using Pascal's triangle. Now combine like terms. And then what we're going to do is to factor this out. And take note, this expression right over here can be factored nicely as a squared plus b squared plus ab raised to the power of 2. So this is the equivalent of sum of fourths. Now let's set aside this result. Now, let's get the numerator, or our numerator. We have sum of squares and sum of fifths. And then what we're going to do is to simplify its factor. Because take note, we have a common factor here, a squared plus b squared plus ab. So we can rewrite this as raised to the power of 2. Also, we can multiply these two to negative 5ab. So this result to negative 10ab times a plus b times a squared plus b squared plus ab quantity squared. So this is now our numerator. So let's set aside this. Now let's get our denominator. So the sum of cubes and the sum of fourths. Now if we simplify this, we can multiply this, negative 3ab to 2. So this will result to negative 6ab multiplied by a plus b multiplied by a squared plus b squared plus ab quantity squared. Now we have the numerator and the denominator of our expression. So we are now ready to get the value of this entire expression like this. And take note, a lot of terms cancel out. This is just one. A times b on the denominator, a plus b on the numerator, a plus b on the denominator, and this a squared plus b squared plus ab raised to the power of 2 on the numerator, and the same thing on the denominator. This is just one. And also, negative over negative is just positive. So what's remain is just 10 over 6, which simplifies to 5 over 3, which is our answer to this question. Therefore, given that a plus b plus c equals to 0, then the numerical value of this entire expression simply equal to 5 over 3. So using Pascal's triangle. Now, let's begin with our second solution. This is quite simple and easy as long as we know the identities. So let's begin with the Vieta's relation and with some touch of identities. Alright, so this is the Vieta's relation in cubic equation. So given that alpha, beta, and gamma are the roots of ax cubed plus bx squared plus cx plus d equals 0, using Vieta's relation, we can easily get the sum of its roots, sum of pairs of its roots, product of the roots, etc. But we are interested to the sum of squares and the sum of cubes. Now, on our given situation, the roots of our cubic is a plus b plus c. So we can set that s simply equal to the sum of the roots, or the sum, and r be the sum of pairs, so which is ab plus bc plus ac, and p as the product of the roots a, b, and c. Now, there's a special case when the sum of the roots is equal to 0, or a plus b plus c equals 0. Now look at this, the sum of squares. Take note, alpha squared plus beta squared plus gamma squared equals to alpha plus beta plus gamma raised to the power of 2 minus 2 times sum of pairs. Now, since we know that the sum of the roots is 0. So this part is just 0. In short, we can say that the sum of squares equals negative 2 times r, or the sum of pairs. Also, given the sum of cubes, we can rewrite this since we know a plus b plus c equals to 0, or the sum of the roots equals to 0. So we can say that sum of cubes equals positive 3 times p, or the product of its roots, or ABC. Now we can extend this because we can rewrite sum of fourths as 2 times sum of pairs raised to the power of 2. You can verify this on your own. And of course, sum of fifths, we can rewrite this as negative 5 times the product of the roots, or p, times the sum of pairs, or r. Now, using the value of these four identities, we can now find the value of this expression right over here. So let's do that. Now on the numerator, we have sum of squares and sum of fifths. Now multiply negative 2r multiplied by negative 5pr. This will give us positive 10pr squared. So let's set aside this, and now let's get our denominator. The denominator is sum of cubes times sum of fourths. So 3p multiplied by 2r squared. This simplifies to 6p r raised to the power of 2. Now we want the value of this entire expression. So let's divide these two equations like this. And take note, pr squared will cancel out. This is just 1. So what's left is 10 over 6. And this simplifies again to 5 over 3, which is our answer to this question. Therefore, given that a plus b plus c equals 0, then the numerical value of a squared plus b squared plus c squared multiplied by a raised to the fifth power plus b raised to the fifth power plus c raised to the fifth power all over the product of a cube plus b cube plus c cube multiplied by a raised to the fourth power plus b raised to the fifth power plus c raised to the fourth power simply equal to 5 over 3. And as always, we are done. And of course, let's have some extra challenge. So given a plus b plus c equals to 0, you can use the two methods I use in this video to answer this, or to get some pattern to answer this. A cube plus b cube plus c cube is 3. A raised to the fifth power plus b raised to the fifth power plus c raised to the fifth power is 0. And the question is, what is the numerical value of a raised to the power of 2025 plus b raised to the power of 2025 plus c raised to the power of 2025? By the way, I will upload a video solution for this question. So see you on our next video.